actually the failure of communication. Okay, so these two things I think I will answer separately, these questions, and I will give it to him as a note tomorrow. Probably I will send it to Senthil Kumar. He can circulate it. And this particular subject will also be dealt, I think, tomorrow afternoon, and then we will talk more about that in detail. But beautiful questions were having asked. I invite more questions also so that I can answer those things. Okay, no problem. So now we will go for the session 2 presentation. So, okay. So here, very important aspect is, now we are starting at 4:05. So we will complete the session at 5, uh, probably 5:50. So that will be 1.5 hours. Okay. Because we have lost almost about 20 minutes. So we will finish the presentation and then we will ask questions if any. So we will, we should have completed it at 5:15 had we started at 3:45. Since we are starting at 4:10, so we will complete at 5:40 or so. 5. Okay, is it all right? Okay. So we will complete this presentation because this contains very useful information, and we will address these things, right? So challenges in smart meter implementation, AMI system, operations, maintenance of AMI components. So
Excuse me,
these.
sir.
Hello?
Sir, excuse me, sir. They want to stop by 5:15, sir.
They want to stop by 5:15.
5:15, sir.
Oh, okay. Because we have started very late actually.
Yes, sir. I know that, sir. We can continue in the tomorrow session if anything left.
Okay. Because continuity is important actually, anyhow.
Okay, sir. I will ask them, sir.
If you can take their opinion, so we
Okay,
can.
sir. I will
Improve.
ask them, sir. I will ask them, sir. We can continue the session, sir.
Okay. Because this is a lengthy presentation. This requires 90 minutes actually. Okay. Okay, no problem. So in this presentation, we cover the following. Number one, basics of AMI and requirements, functions of AMI, architecture of AMI, Indian scenario on AMI, integrated testing and validation of AMI. So these things we are covering here in this 90-minute presentation. Okay. What are the basic AMI requirements? Okay, that we will see now. You see, look at this particular diagram. Here we have a home. Here, this is the smart meter. This is the modem, and this is the data concentrator DCU, which is housed on the pole-mounted meter. And this is the head-end system. From the data concentrator, it goes to the head-end system, and head-end system it goes to the data management, meter data management from the customer service angle, and this goes to the customer and operator. So this is the lower end, intermediate end, upper end. Okay, so this is how it is. Mainly encourage customers to reduce energy consumption, okay, voluntarily by identifying real-time power. Okay. Second thing is it provides an infrastructure for demand response. Demand response is what? Responding to the demand for the customer meet requirements through two-way communication and data processing system. Okay. So AMI consists of upper system. Upper system is MDMS, meter data management. Okay. Second is intermediate system, head-end system, which gathers the metering data from the lower system. What is lower system? Lower system is a system which includes smart meter, communication modem, and data concentrator. This is how the structure is actually. Okay. So this is the smart metering system, particularly the smart grid advanced metering infrastructure. Okay. This is HAN, home area. This is the communication, maybe RF. Okay, as have been told here, maybe mesh communication, peer to peer, whatever it is. And you are having here the wide area network, right? So this is the meter data management system, which collects the data, validates the data, and then goes to the AMI management. So this is how the infrastructure, particularly what we call the structure of the inputs are there actually. Okay. AMI is an integrated system of smart meter, data management system, and communication network. It will enable two-way communication between the utility and the customer. Okay. So the AMI is the collective term to describe the entire infrastructure mechanism from what? From smart meter to two-way communication network. So that to control center equipment and all the applications that enable the gathering and transfer of energy usage information in near real-time domain. Okay. So AMI makes two-way communication with customers possible. Okay. And it is the backbone of the smart grid, because two-way communication is something he has asked the question, about the reliability of communication, which I'm going to talk actually probably tomorrow, and I will also address that. The objective of AMI can be remote meter reading for error-free data, network problem identification. That is, network problem identification is what? It is the identification of the problem in the communication network system, and profiling of the load. Okay. Audit of energy, and partial load curtailment. Partial load means what? The load which is not required actually. Okay. Right. So this is what the advanced metering infrastructure does it. Why AMI? Number one, it is a digital infrastructure energy. Number two, it provides demand response for renewable energy platform. Number three, it provides the time of use. Okay. Time of use is what? How you use the electricity. Like, the differentiated tariff, the business relationship, efficient operation and maintenance manager, human energy. Okay. These are all things very important. And loss detection and remote control. Here, reduce and minimize the loss in the field. Technical, non-technical loss like tampering, efficient operation and control of energy resources. So this is why AMI is required. Major benefits. Number one, enhancing customer benefit. Like what? Billing. No need officer to visit the meter. No need officer to visit the cutoff electricity. Okay. Second is customer satisfaction. Ensure higher customer trust. Number three, enable customers to access real-time energy. Number three, very important, higher stability and reliability, quick detection of abnormal distortion line, more accurate forecasting of energy consumption. Okay, quick response for customers' complaint, like, recover blackout even before customer notices it. Officers can visit customer for changing power limit because customer ask for it. Okay, so this is how the whole philosophy is being driven through. So this is the benefits realized out of smart AMI. How it is? From the utility financial benefits, like the commercial benefit, operational benefit, consumer benefit, societal benefit. From the commercial benefit, collection efficiency, as I told you in the previous presentation. Okay. Reduced PPC, that is, the power purchase cost, because you are integrating that, with the solar and distributed generation you are making. Okay. Reduction in transformer failure, because transformer overload is avoided. Commercial loss reduction, right? In the operational benefit, we have the technical loss, reduction in the meter failure, reduction of the cost, particularly meter cost. Okay. Meter reading cost, this we have discussed already. From the consumer point, billing. Okay. And also consumers rental earnings from leasing rooftop. This is very important, because the rooftop solar energy is being leased through, or it is going through a different model which I am going to discuss tomorrow. Okay. And then it will have an impact on the leasing to the utility. Okay. And direct and indirect jobs created due to investment and ongoing services related to AMI. So reduction on oil import, because you are now going for electrical vehicle. So how much the oil has increased actually today, and you have to avoid that to have a better impact on the society. Like what? Reduced carbon monoxide, reduced nitrous oxide, sulfur dioxide, carbon dioxide, and also it will create a clean environment, because the distributed energy will give you what? A distributed sort of energy management, with which it is possible for you to focus on what we call the conservation of clean energy, clean digital energy platform. This is another important aspect of the benefit raised for the AMI. This is a model developed by Infosys for the AMI solution. Okay. Here there are two things. One, the blue color, other is the black color. The black color is the core application, and the blue color is the optional application. The black color is actually the meter is red, the core application. Meter is red, meter is communicated, and data management, customer care billing. And finally, it is integrated. In the optional arrangement, you have the business, but in the sense, AMI bus intel application. That is, the arrangement, with which it is possible for you to focus on what we call the derived technology, like the Wi-Fi based application. Energy management is another tool with which it is possible. Okay. And then load forecasting, asset management, outage management, responding to the demand, and revenue assurance. This is how the solution on the AMI platform is being driven through. This is the legacy system. What legacy means? Old. Consumer, meter, utility. Here, the communication cannot be done. Electricity meter, cannot communicate to and from consumer. Okay? It's one-way communication. That means whatever happens here, you will just record it, and then you can give a feedback after the event is over. Whereas the new system of AMI is this actually. Here you have the consumer, meter, you have the LAN, local area, wide area, meter data management system, utility. And here in the home display, smart meter, bidirectional AMI communication, maybe RF mesh, PLC, BPL. BPL is broadband over power line. Okay. And CDMA. You are familiar with CDMA. That is, earlier process, a code division, a multiple access. Okay. And then this is the meter data management system and utility. This is how the new system is coming into picture. This is the new system, old system. We will talk more about it as we proceed further. This is how the evolution of AMI technology has started. Okay. Remote meter reading, we call RMR. This was being used, till 2010, and then we have started using this. And even today, I think probably remote meter reading application is available. Okay. Remote configuration and real-time communication has started in 2013. And then, in-home display, remote connection, outage notification, we did this exercise till 2016. And in 2017 we adopted in what we call, the time of use and energy management system. And today, we are going to what we call ultimate in the AMI technology is the demand response. So this is taken from Frost and Sullivan, who has made a presentation, in the international arena on the response of AMI technology evolution. Okay. So this is how the AMI technology has evolved. Okay. Like, red color is low, yellow color is medium, and green color is high actually. And you can see 2010, 2015, and 2022 how the evolution has taken place. Okay. And this is material will be available to you, and you can only discuss it in case any question is raised at the time of presentation. Okay. The evolution of meter reading. This is important. In the past, one reading per month. In the past means even today, 1 meter per month. Because 250 million meter, only when they are replaced by smart meter, okay, which is a very, very, very big exercise, for which, this training is being forecast. Okay. In the past, reading meter only aggregate data. One month reading he will take, he will issue the bill, you will pay. Okay. And that is the end of it. So this is what we call aggregate data. A smart meter will do what? Smart meter, 15 minutes, it will have reading, meter reading, and calculations per year for a utility with 100,000 meters will generate 3 billion 456 million data. 3 billion 456 million data. This data is known as granular data. This data is used for your billing purposes and other applications, including power theft, including power management, including energy conservation. Oh, you got my point. This is a very, very important message. So this is done by what we call as big data analytics. Okay. And this is done by a technology which is also known to you as Hadoop technology, which will have an impact on the overall scenario of implementation of these meters in the real-time measurement. So this is a very important message. Keep it with you, and then we will discuss more actually when we have the time actually to discuss about the communication also. Okay. Probably tomorrow I will talk to you about communication. In the meantime, the the question asked, by one of the engineers, a very good question about, the 70% data conversion and failure of communication. We will address it definitely. Okay. Next, it is about the data analytics. How many meters are reporting? Which substation are missing the most data? Total usage by substation, highest consuming meters by day, peak hours of the day, and list goes on. It's about data analytics. Analyze the data, validate the data, okay, estimate the data, edit the data, VEE. Okay, this is the sequencing with which we have to make our analytical data problem. Okay, it is a systematized approach for conservation of energy. Okay, energy conservation is very, very important from the point of what? From the point of AMI incorporation. Okay, what are all the layers of AMI? So, an advanced metering infrastructure is a complex network mechanism. Okay, each system architecture has at least two, sometimes three separate network. For example, the top layer is the public network, generally TCP/IP, that is Transmission Control Protocol or Internet Protocol. So this layer is called Wide Area Network, WAN, WAN, and sometimes a backhaul. It's also called backhaul communication. We have middle line, last line, and then like backhaul. Backhaul is some WAN communication. So the second layer, very important, is the proprietary to the AMI vendor's design. And the third layer, so that means to say second layer is the proprietary. He will not divulge about this particular thing unless it is an agreement between the utility and AMI manufacturer. Okay. The third layer, if there is one, is a very, very important, which uses a standard design. So with the latter, that is the third, it appears that Zigbee, which is the communication, is winning this battle. So at least among AMI system, what we have to do is if they have a third layer, this extends the AMI system firmly into the general Internet of Things, IoT. So adding a third network layer designed to penetrate the home can extend this network to devices in the home. Like what? Like HVAC, heating, ventilation, air conditioning, thermostat, where higher loads are there. We are focusing on domestic because the smart meter, what we are intending today, most of the cases and large population is domestic meter. Okay. So about 70% and 260 million meter is the domestic meter. And the rest is only 35%, 35%. And the revenue from home is less compared to revenue from the high-end meter. High-end meter is what? The CTPT operated meter, high tension meter, boundary condition meter, very high accuracy meter. These are all the things. We will talk more about it. Don't worry about it. Okay. The commands and information sent to and received from these devices are very simple. So the third layer can be slow, but it must be secure and inexpensive. Some devices in the layer are battery powered so that it should be low power. Okay. What technology? Okay. For example, wired. Wired is what? PLC line. Okay. It is offered by carriers like AT&T. Okay, wired and optical network offered by cable carriers like Comcast. These are all manufacturers. Of course, in India also there are several manufacturers, who will definitely supply these things, in association with the foreign uh, technology partners. Okay, optical network offered by network service provider like cogent communication. Okay, wireless network. These are all the technology based solution available today for the application. Okay, so there are major thing in the AMI technology is communication, the communication system. Okay, the second is distribution automation. Okay, maybe that's SCADA based, HMI based. Okay, the third thing is outage management. All or virtually all AMI system can detect when each endpoint meter loses power, etc. Okay, so they can provide notification of a power outage, its extent, and extent of restoration. So this is how the technology is being driven. AMI in the present context is what? Modernizing India's grid, number one. Digitizing India's grid, number two. Providing digital platform in the power sector, number three. So during this, actually, it will have system reliability, cost of energy, theft of energy. Electricity theft is a very important factor to be considered. Okay, it's a complex problem today. So AMI systems can track energy usage. It will help monitor power almost in real time so that it leads to increased system transparency. So this is what it is. What are the challenges of AMI? Number one, high capital cost. Naturally, we have to have these systems and the cost will definitely increase because of the system integration. And then second thing is integration challenges. AMI is a complex system of technology that must be integrated with utilities information technology system, customer information system, geographical information system, outage management system, work management system, mobile workforce management system, SCADA DMS system, etc. Standardization of interoperability standards need to be defined very clearly, which is set and uniform requirement of AMI technology, AMI deployment, and operations. They are the key successful factors in maintaining AMI based grid system. This is how the challenges are addressed. Okay. And advanced metering infrastructure is deployed in many countries actually today. As I told you, about 450 million installations all over the world will have these things actually. So AMI enables a bidirectional communication and it reads the electrical consumption at a higher frequency rate. Okay. Second thing is collection of data at each meter is a very, very critical problem. And distribution system operator to better understand the patterns of electrical energy usage so that they can elaborate the market signal and understand the behavior of the customer. What are the main issues and challenges of AMI? From the customer side, from the consumer side, users need to protect their data protection. So this data protection is very important. Okay, and it creates need for proper data management. That is why the big data is used here. The second is utility company need to be sure that the data is accurate, data is precise, data is integrated. In the sense, integrity of the data is not to be doubted at all. So physical or cyber attack is very important. In fact, I am discussing cyber security also to a large extent tomorrow. Okay. So managing the negative public reaction is another important challenge. And also it ensures the customer acceptance for the new meter and difficult matters also it will be in a position to make sure that the work situation is provided in the entire notification management. What AMI consists of? What is this actually? Number one, it consists of smart meters. It consists of data concentrators. It consists of wide area communication network WAN. It consists of meter data central system, MDC. It consists of meter data management system, MDM. It consists of HAN, maybe WAN, maybe. Okay, all these things is nothing but the product integration of AMI. So that means to say AMI is a system. AMI is not a product. In the sense, it is not an individual product. It is a system integrated solution. Let me make it very clear. Okay. And we will come to that later on when we understand, how the integration is being contemplated. Okay. What are the main components as I told you? Smart meter, communication, head end system. Head end system is also called MDA, MDAS, meter data acquisition system. It only acquires the data. Please make sure that head end acquires the data, whereas MDM cleans, validates, processes the data, and it gives you the billing. MDM, okay, and handheld unit HHU, okay. HHU is a digital assistant which will give you the information on the entire structure of the metering in the networking philosophy. Mobile app is another important thing. Consumers shall be able to log through an Android based mobile or iOS based mobile, okay. So the information related to his energy consumption can be captured, okay. So interoperability is very important, okay. The contractor must provide at least 10 numbers of single or three-phase smart meter at different make, which will make an integrated HES and MDS. This is a very, very important challenge. Today, when you buy meters from different sources, okay, in India, there are about 25 to 30 meter manufacturers. Each meter must be integrated without any sort of issue. Communication, not only communication, even software, hardware, and other perennial problems. Okay, this is how we have to discuss that in this particular forum. What is AMI platform? AMI platform is a simple platform, okay, which will have a driven regulatory factor, okay, for deployment. Okay, from the utility angle, the AMI platform allows for a traditional manual reading, moves to what we call the operated the reading, or that is the automatic reading. Okay, as a consequence of these driven parameters, AMI platform is a win-to-win exercise for both utility and customer. Very important. What are all the functions of AMI in this particular presentation? You have the LAN, okay, and this is the WAN and NAN, wide area, neighbor area, data concentrator, central system, and you have the HAN here, home area, which is integrated distribution generation, PV, wind turbine, okay. This is PEV, PHEV, nothing but the plug-in hybrid electrical vehicle and plug-in electrical vehicle, storage, smart home, smart thermostat, in-home display, meter. Okay, this is how the hand segment. In the NAN and WAN segment, we have this is the integrated solution. You have to understand this totally pictorially because from LAN, WAN, NAN, HAN, we have to have a total structured by-way communication system. So this is the land structure is used mainly in the private realm. Private means the exposure is the private users. Okay, private users means home, industry, maybe even commercial establishment, etc. Public means hospitals. Okay, transportation system, government offices, railways. These are all the public actually. So this is the integration solution of an AMI networking philosophy. Okay. What are all the operational challenges? Number one, you have to select a good model. This we will discuss separately, capex or whatever it is. Technology architecture, like the Matey empaneled cloud vendor. He's a vendor of Matey is a vendor of cloud, an international company. Okay, optimized design of architecture. Okay, next meter implementation. Meter implementation means meter implementation maybe from the customer interface angle, CI. Okay, experience, QA, that is quality assurance, quality control, okay, and monitoring of the data, adherence to the field and SOP. SOP is the standard operating procedure. Okay. Next, we have to go to the supply chain management on behalf of how the supply chain management will have an impact. Like good quality of smart meter, synchronization of meter supply and meter installation practices. Okay. From the telecommunication angle, we have, the network coverage, like failure of communication. This is very important because, today's communication technology, as rightly pointed by one of the participants, then naturally the 70% penetration will cause a lot of concern actually. And you have to have 100% communication system, because what you communicate, you should get. What is lost is important actually. And 70% is something, which is phenomenal. But however, with technology, we'll definitely speak about it and we will address that actually. Integration, support from external stakeholders, finalization of approach and methodology. All these materials we will make it available to you, so that it is not the question of understanding, it is the question of preserving that. And make sure that when you install these meters, when you apply these meters, when you test these meters, these information will help a long way to give you the present technology needs and present technology conditions. Okay. Meter advising. What is meter advising? Planning where to use the meter, which capacity, which accuracy, which is the sequencing. This is meter advising. And then billing, a provision of CSV. CSV is comma separated value. So that is a file in the HES system, which feeds the billing system actually. Okay. And then user acceptance testing, UAT we call, where is the compliance, validation, acceptance, integration. This is done. And then billing cycle and SLA monitoring. SLA is the agreement level. How you have formulated from AMI to HES, HES to MDMS, MDMS to cloud, cloud to system, like that. Real-time system generated SLA report. Okay. Monitoring of the data, monitoring of the dashboard system, monitoring of the daily, weekly monitoring system. Okay. These are all certain things, which go peripherally to make sure that operational challenge is being met with. This is a line diagram of model approach. We call model line approach, AMI project. How AMI is systematized, how it is engineered, how it is connected, how it is integrated, how it is synchronized, how it is made into practice. This is what I am going to discuss in on the 2 3 slides actually. This is a smart meter. Okay. GPRS communication, HES, it goes to MDM, bidirectional here, and then it goes to master data sync. This data is sync here. That means whatever the MDM and other things are carrying here, it is sunk to the generated billing mechanism system. So it is a meter here, integrator, system integrator, which integrates the total system. This is the distribution company premises where meters are verified, meters are accepted, meters are adopted, and then it goes to what we call CCB, CC and B we call customer care and billing. So here the meter is advised. Advised means what? As I told you, which meter, which make, which accuracy, which technology, which interoperability, whether it is DLMS, whether it is COSM, whether it is OBIS. So these are all things which will have a question. This is how the AMI is in general being inculcated. We have to see each function, and then we have to make sure that each addresses all the requirement of the generation mechanism. So this is, are you clear now? Because this is very important. Next, when you see, it is addressed with typical meter number, typical HES number. You can see here. This is the meter number. This is the badge number. This is the make of the meter. This is the MCT, that is, the CT operated system. Okay. Metering CT we call. And then here, the number 55470, 55470. This is what we call, this is integration. Here, 55470, integration. Here. So the meter data is not sunk yet here. It is synchronization has not happened. So when if synchronization happen, then only you can move further. You can see the next activity. The next activity, here it is not communicated, but master data is sunk actually. Okay. Next, when you see, the whole thing is systematized. This is the real main challenge approach in the illustration, where you can get the meter, the GPRS, the HES, the MDM, the CCB, the DISCOM, and the entire thing is being systematized here for the practice of application. Okay. Next, Indian scenario. India's energy scenario is very important. Third largest production. The world loses 89.3 billion annually through power theft. India loses 10 to 15 billion annually. 250 million, not 40. In fact, 260 is the correct figure. Indians live without access to electricity. This is the population actually. Okay, for generation, availability of fuel and renewable energy infusion has been addressed. Additional transmission capacity, inter regional capacity is being addressed. Okay, so this is the struggling of distribution sector today. So India's power sector and overview uh, has been brought out here. 260 million meters, very high loss, 23 to 25%, low revenue per capita, 1010 kilowatt hours, load growth expected 6 to 8%, peak shortage, energy shortage, energy produced around 1200 terawatt hours of energy is being produced, still insufficiency. More you produce, more the loss. That is not the solution. You have to integrate in the distribution system, distribution management, distribution energy sector. Okay, both central and state government involved in the power sector management application. Okay, so information needed for distribution management, what is this actually? Here, this is the information from the customer angle, from the accounting and payment angle, from the meter reading angle, from the meter profile angle, from the geographical location angle, from the asset management angle, and also from the load profile angle. So this is how the need is there through smart metering system. Like what? System maintenance, automation, expansion, design the tariff, power quality, communication management, customer billing, customer collection, managing the credit. So these things are very, very important from the AMI angle. Discom story is not very important for us, and status is also not very important. Drivers are important. Drivers, what are the drivers? Number one is the transparency. Number two, reduced theft and reduced ATC losses. That is the main purpose of this particular seminar, to make sure that it will address how to minimize the ATC loss by smart metering, by AMI. Improved customer service, integration with renewable energy management, load management. So these are all the main things which will tackle the driver mechanism in the metering philosophy. This is what we have to talk, very much important actually. What is this? The key challenge for the Indian distribution company is reducing ATC losses. So UDAY, that is Ujjwal, the to innovative effort to address all the problems related or faced by the distribution company. So it will address the issue of very high interest burden, very effective power purchase agreement. Okay, and also we have shown an elephant here in the room actually. Okay, here this is the elephant in the room. The elephant in the room is high ATC loss. It increases with increased generation. Increased generation is not the solution. Optimize, make use of the available resources. Okay, so therefore, what is this ATC loss? We have been talking of ATC loss. ATC loss is nothing but the actual measure of overall efficiency of the distribution business, as it measures both technical and commercial. So energy realized is ATC loss is nothing but energy input minus energy realized into 100 divided by energy input. Of course, the collection efficiency and other things are coming into picture. So this is how we have to understand the root cause of ATC loss. The revenue loss is prorogated by three main important factors. Number one is the uh, non-technical, commercial, technical. Under non-technical, you have the metering related loss, like the tampering, data fraud, error and defects. On the other side, this is a very important. Unmetered supplies, plenty of there actually today. Illegal connection, okay. And the commercial losses, we have commercial practice, that is the data flow, long cash cycle, very important. In the debt management, the commercial, as we have, they don't pay, they cannot pay. These are all the two categories. In the technical loss, we have unavoidable losses and avoidable losses. We will tackle these things in the ATC loss mechanism, and how AMI introduction can reduce this. and with what figure we want to see, and how we can excel is the important aspect from AMI. This is very important to study the whole philosophy. Okay. So challenges in Indian context. Challenge with utility, complex meter design. This is something which is very important. We will talk more about it. Poor electrical system that could lead to several factors like geography, surges, spikes, etc. Okay. High ambient temperature, dusty, humidity, and poor installation practices. These are all the phenomenal thing which will have an impact on the AMI. Okay. So there are main focus is people, technology, process. They are contributing for the technology upgradation exercise. Okay. Worldwide AMI projects. In USA, 100 million, around 100 US dollar. Okay. In United Kingdom, 60 million. Okay. In Australia, 2.9 million. In France, around 35 million. So huge things are going on today in the wide worldwide market. India also should come into picture, but Indian base is insignificant compared to the population. Anyhow, we will talk more about it. Don't worry. Okay. And of course, this replacement plan is not very important for us. We will discuss at a later stage. Okay. So AMI system architecture is something which is very, very important from the point of understanding. This is the customer data collection, communication network. This is the utility third party data reception and management. And you have the AMI, advanced metering infrastructure. That is what it is coming here. Okay. And this is the meter data management system as a whole. Okay. Philosophically, we have to understand these things, from the point of the technology and point of upgradation of the system. So this will take care of your the entire meter management block. This is the AMI block with which we are working today. Okay. So we will see first building blocks. Of course, we will see next integration. Yeah, we are here. Yeah. So this is another arrangement with which it is possible for us to understand how the smart meter is integrated into the sector, particularly with regards to operational characteristics. Okay. So this is how the meter is coming into picture. You can see here the left side smart meter. This is the data concentrator, a wide area, multiple head end system, meter data central system. We have the meter data collection, etc. And we have here the enterprise services like management, work order management, ADMS, okay, advanced metering systems actually, meter data management, okay, customer information and billing, load management. So one important aspect here is that how this particular thing is integrated from the multiple head end to the meter data management system and also to the final enterprise service system. And we have here the OSGP, that is the Open Smart Grid Protocol, and this is the DLMS, that is the Device Language Message Specification Meter, and IDIS, that is Interoperable Device Interface Specification. And this goes into the mainstream of application of the smart metering and AMI application. So this is a typical AMI system with which it is possible for us to address the main mechanism. This is the residential area. Here, we have the customer relation management. Okay. Mainly, this is the meter. Okay. This is the PLC. That is, the power line communication transformer. Here we have the DCU, and this particular thing will capture the data and it goes to the DSO. The DSO is nothing but your system integrator with which it is possible for us to develop the mainstream. Okay. Sorry. Okay. Just hold on. Okay. So this is the main thing, with which the building blocks we are discussing. Okay. Here, the subsystem of AMI. What is this actually? We have the billing, okay? We have the uh, work order. This is the GIS. This is the MDMS, meter data management. This is head end system 1, head end system 2, head end system N. And this is the data concentrator. And you have here, the meter data management protocol. This is the head end system with which we are operating upon the number of meters installed and number of head end systems installed for the MDMS. So this will get data. All this data will be fed into MDMS. This is the data concentrator which will supply the data to the head end system. And then these are all the number of smart meters with which the subsystem is being driven through. Okay. So same thing here also, the integration is done on the base of platform, like the customer billing, the work order, okay, the MDMS, okay, here the data concentrator. And you have from the architectural perspective, the universal head end looks promising at first, instead of one integration between MDMS and each of the potentially many head end system. Only a single integration needs to be created and managed. So this is how the whole block of the data concentrator unit in the system of smart metering philosophy, combined with advanced metering infrastructure, which has head end system and MDMS. So, how to make the right architectural choice regarding head end system? So, the right architectural choice is, it is done, by OT, operational technology. Operational technology may be SCADA or maybe ADMS. ADMS is Advanced Distribution Management System. We are not talking more about it because this is one smart meter, and AMI is one of the factors to increase or to optimize the management of not only AMI but also the integral solution. Okay, this is the CIS billing, customer information billing, work order. This is GIS, geographic. Okay, this is what is we call enterprise system, and this is the management system, and this is the head end system. Okay, and this is the communication data concentrator. Okay, and this is the smart meter. Okay, this CIM, what we call here, is the uh, common information model. So common information model is something which is very important to address various technology applications. Okay, because that is coming here, as I can see here. This is the SIM, the common information module, and EDA is one of the tools actually. This is event driven architecture is one of the tools, and it is a software architecture. And this is mainly the real time streaming of the data for providing the head end application. Okay, components of AMI, which we are talking, the smart meter, which corresponds to the application of IS 16444. So it measures various parameters like the active energy, reactive energy, apparent energy, power factor, voltage, frequency, so many parameters. So this is definitely an important aspect to be noted now. Communication, we have different modes like either HAN, FAN, field area, or WAN, wide area. We will talk more when we address the communication system. The MDAS is nothing but HAS. This data acquisition system. It acquires the data from the field device and analyzes it and reports it. So the MDAS can perform data acquisition, connection and disconnection, audit trail, maintain time synchronization. Okay, and MDMS will do data management like customer information, outage management, and it can integrate with ERP, GIS, etc. Okay, MDMs performs a lot validation, editing, estimation, VEE. So this is how the component mechanism of the AMI mechanism is being worked out actually, and this is a very important tool to address the most important aspect of our advanced metering infrastructure. How AMI works? Smart meter, as per IS 16444 or IS 15959. So this is radio frequency, IEEE, which will address 802.15 router. So here you have the different communication. Okay, this will go to the long haul network. This is long haul network in the sense, the network which will cover the distance wise on the periphery of the meter integration system. This is the control center for the head end and MDM data. Here you have the data analytics like load forecasting, okay, and then revenue management system, revenue production system, peak load management, PLM, okay, and then tamper analysis, that is very important, and also energy accounting, energy auditing, loss management, and also it will have a prepay scheme. This is how the AMI works actually. This is how it is very important to understand how the AMI works from smart meter to networking to the control center. So this is how control center will have the head end system, the MDM, etc. So now you can ask a question: where is head end system located? It is at the corporate level. Okay. Where is the smart meters located? At the premises. The integration is done based on several philosophical things, on either 3G network, 4G network, or NBOIT, GPRS, whatever. This we will discuss more, when we talk on the communication. Okay, this is the architecture of an AMI. Here, we have HAN, home area communication, consumer, smart meter, wide area network, AMI, MDAS or MDMS. This is going to billing, OMS, that is outage management. There is nothing but connection and disconnection. Okay, other systems like the data management, etc. This is how the architecture of a typical AMI system is being worked out actually. Okay, system test, that is very important actually to understand how the AMI is tested actually. So this is taken from Capgemini LinkedIn slides actually. Capgemini is one of the main validators or main suppliers of the AMI system in the international arena. So we will see how this is done. So testing for AMI system installation. Testing of the software is most important. Okay, like MDM software, outage management software, customer information software, billing software. Okay, next, it is imperative that each of these system components meet the functional requirement and non-functional requirement. Okay, next, to meet the business and other performance security requirement, the AMI testing offering provides ready to go assets. Okay, this is how the testing system is being driven through. Integrated testing system. Testing of smart meter is one thing which we have discussed already. Second thing is testing of framework, which starts with unit development testing of component and interface. AMI testing framework divides the testing life cycle into 4 generic phases with clean set of activities for each phase of networking. So this is how the framework is being driven. Smart metering implementation test life here. Okay. Here this is the test strategy, test planning, scripting and data preparation, test execution. So this is the security test strategy. Okay. And then here, this is nothing but your the leads which are taken from the company, like the UAT plan. What is UAT? User acceptance testing. User acceptance testing is a type testing phenomena by the end user or by the client to verify, to accept the software system before moving the software application to the production system. Here it is a pre-production run. Here it is the performance run, integrated run, development run. You can see this very, very nice slide actually, which gives the complete comprehensive arrangement of the AMI testing. Here, this is the test specific development. This is the test preparation, how you can prepare. And here, you can execute the test. Environmental testing, unit testing, compartment testing, system integration, or means what? Regression testing. Regression testing is statistical analysis actually. Okay, stress performance testing, industry testing, and we come to what we call UAT. UAT is user acceptance test. This is how the whole phenomena of the testing mechanism with which it is possible for us to focus on what we call the AMI smart testing. And here we have the asset accelerator. Each is described here, phases, and we have here the standard with which the AMI test is driven. Okay, AMI test, standard, test plan, system. This is EUC testing. EUC is end user computing system actually. This is a test engine for the inbox created data, and then model based testing where automatic test and authenticated testing sequence is there. And then here the tool where the generic framework is being tested for operational characteristics and also for carrying out the modes of operandi in the orthogonal array testing. Orthogonal array is also what we call as a statistical testing to make sure that the sampling plan is in line with your requirement. This is how the AMI has been evaluated actually. This is AMR, automatic, here advanced metering, automatic meter reading system, AMI, and then smart grid. And then we have started replacement of meters, AMR 1994 to 2006, AMI 2006 and beyond, and 2009 and beyond. Functionality like dynamic pricing, demand response, personal energy management, distribution automation, substation automation, volt war balancing, fault detection, renewable integration, distributed energy management, meter tampering data system acquisition. So this is how the global evolution to smart grid mechanism is being driven through. Okay. I think we have understood already how the AMI will work and what will be the benefit. This particular thing we have discussed. In India, what will be the actual AMI requirement we have to see? Number one, demand shortage. Number two, theft management. Number three, load control. Number four, system automation. Number five, better system economics. So, in fact, we have taken action to step forward in long-term AMI direction by defining what we call the RAPDRP scheme. And now the RDSS scheme is also coming up, which will give you several incentives with regards to use of tool, use of software, use of new technology, and use of the application oriented system. Okay, combination of radio frequency, DLC, GPRS. Okay, this is the communication with which we will elaborate definitely on this and functionally find out how which suits you and what makes you to understand this philosophy. Okay, we will see further functionality, of course, from the customer angle, like the time clock synchronization, load control, event management, home area interface, tamper detection, reversal of current, cover and terminal cover open, detection of meter tampers, removal, okay, remote firmware upgradation. These are all the functionalities the AMI does it without any sort of deviation in the mechanism with which we are thinking to measure the functions, main functions. So like in RMR, TOD, prepaid functionality, net metering, we will discuss this separately. Alarm event detection, like notification, remote load limiter, remote firmware, okay, integration, import of legacy data, security data, and also data accessibility. These are all the main functions with which we are having. Planning, of course, we discuss this in general, but in specific, we have to make a total AMI plan. Okay. Main challenges of this particular AMI mechanism is integration, standardization. What is integration? AMI is a very complex system of technology that must be integrated with utilities information technology system, which includes CIS, geographical information, GIS, outage management system, OMS, work management, WMS, mobile workforce management, MW. This is like very important. SCADA, DMS distribution. Standardization interoperability standard, it needs to be defined which set uniform requirements of uniform technology, deployment, general operation, and which particular technology suits what, and which technology will definitely have an impact on your application for different application, defining what needs to be done to maintain an integral platform of AMI mechanism. Okay, subsets of AMI: meter, maybe three phase, single phase; communication, maybe PLCC, ZigBee, GSM, GPRS; data concentrator, DCU; meter data management, MDMS. These are all the subsets of the AMI system. So you have to have the operational and maintenance of AMI, like how to maintain How to operate an AMI? The advanced metering infrastructure is typically structured into bunch of network and composed of few major components. Like what? Next figure, it will give you an indication of all components and most network. It is made up of meter, collector, server, and the distribution system operator. And also, it will give you the company side. Okay, this is how the philosophy with which we operate. Let us take this actually. Here, we have the head end system. Okay, firewall is to protect actually. This we will talk when we talk about cyber security. Okay, and then here we have the DSO is actually the distribution system operator, and the DMS, the demilitarized ones. Demilitarized means, as I told you, licensed and unlicensed. Okay, this is a WAN actually, wide area. This is a NAN, where you have the meter, and then the meter will send the uh, packets of relay application to the meter from the NAN and also to the system. This is how the network works actually. We have to see how it is maintained actually. That is important factor for our understanding. So what the meter consists of? The meter consists of, for example, the meter consists of the you can see here the transformer, power supply, rectifier, regulator, display. Okay, then you have the modem, you have the this is ASM, that is nothing but an assembly language system, Max actually. This is the series microcontroller. Okay, 8051 or whatever it is, the application is left to you. Here you have the energy meter, a load, LDR interface. So this is the block diagram of a typical IoT based. How to maintain is, you have to open this particular set technology into system. How to maintain? For example, the electronic meter will take care of its operation and maintenance by the qualified engineering person who has been specially trained, for maintaining the meter. Okay, you just cannot open the meter unless you are confident of doing it. And naturally, the meter should not be opened unless you are having adequate knowledge. It is like opening a black box, and you will not get into any sort of information unless it is you are trained in this. So therefore, training is very essential to understand the captivity of this system, understanding of the technology, and then you must maintain it properly to make sure that this works in the required application. All smart meters shall be duly tested, sealed. As I told you, the smart meter is tested in line with IS 16444. Next is communication. Communication meter shall have ability to communicate with data controller, access point. One of the technologies mentioned in IS 16444 is a secure manner as per the site condition and as per the design requirement. Okay, of AMI implementing agency. In case, okay, so in case, very important, in case GPRS, 3G, 4G meter, the meter shall accommodate SIM card of any service provider. This is interoperability. So in case of plug-in type communication, the meter shall log communication module, its removal, its non-responsive event with a snapshot. So here, the failure of communication is also coming into picture. So you must also be trying to make sure that the communication module is maintained by a qualified meter engineer, qualified telecommunication engineer who will have basic knowledge of communication engineering technology. So don't get into the complex modes unless you are thoroughly knowledgeable in this area. Okay. AMI installation, maintain. How it is done? Check for the suggested functions like HAS. HAS will do what? Acquisition of metadata and user selectable periodicity. Okay. Communication module system, communication data generation, signal for connection and disconnection, maintaining time synchronization, adaptability, acceptability, system integration. These are all main things, where the HES maintenance system is coming into picture. Okay. So now, we have come to almost the conclusion of this particular thing. In recent years, with advancements of telecommunication and information management system, the technology and increasing requirement of various sectors of the power industry, monitoring, managing the data, monitoring, managing the AMI is playing a vital role in power management system of distribution sector. Okay. The power companies will face two major challenges. One is, the cost of implementation, and the second is the complexity of the system to be addressed to make sure that failure rate is very, very less actually. So this is what the important aspect. AMI faces many challenges but has the potential to greatly increase the energy efficiency. In fact, you can see here how the important message is given. This is the percentage of revenue. Okay, this is actually the main factors: the utility angle, agriculture, printing, clay stone, retail industry, aircraft industry, durable goods, healthcare, office mechanism, energy management service, electric utility. You can see here, this is very important, less than 2% R&D as a percentage of revenue. So therefore, it needs that we need to focus on not only R&D, but also to understand the overall technology with which it is possible. So the advanced metering infrastructure are systems that measure, collect, and analyze energy usage, communicate with measuring devices such as meter, either on request or on schedule. Okay, these systems include what? Hardware, software, communication, consumer energy, and controllers. So the customer associated with the meter data management software and supplier business system is a very important entity to address the system. So this is how the system is coming into the picture now. Now I think we have uh, finished this, and then we can go for any session questions on the focused point. Then we will discuss that actually. Okay, mainly on the presentation made, and the question which is asked, here will be given. Definitely, it will be addressed tomorrow, or if you have time, probably we can take it today itself. No problem. Okay. So, any questions related to the presentation today? Yeah.
The question is there.
1 minute. 1 minute. Hold on. Just I will come back to you. Okay. Yeah. Tell me.
Yeah, good evening, sir. For your information. So I have
Hello.
finished the presentation, sir.
Hello.
So I have finished, sir.
Hello, sir. Hello. I am not listening, sir.
So is it clear, sir, for you, sir?
No, it is not audible. Now you are, please. Keep the microphone away from your mouth so that it will not interface. Distance is important.
Sir, please. This is the microphone.
Ah.
Sir, regarding this, we have that aggregate data and annual granular data is available now, sir. So this granular data is enormous when compared to the aggregate data.
Okay.
So we are storing this granular data in the hidden system
Yeah.
over a period of say 5 to 6 years as per the project period.
Ah.
So what I feel that it is a very big challenge for storing this data
Yes.
for a period of 5 years or so.
Yeah.
Comparing that data storage cost
Yeah.
whether it's cost effective of the smart meter when compared to this data storage with respect to the legacy system.
Yeah. Very nice question. I'm very happy. In fact, the interaction is good. You see, I will tell you. One is optimization. Optimization in the sense, when you buy a smart meter, there is a set of specification with you. When you buy, the head-end system, naturally specification has been agreed. Even for MDMS, okay, the integrated solution will have a tendency on the optimal cost actually. Number one, the storage mechanism, particularly the storage, data storage, etc., is to be well defined by you while procuring this particular head-end system and also MDMS. And then you should come to an agreement with the manufacturer to see that the data storage mechanism, the data storage availability is enough for storing 5 years data. That must be in the contract. Once it is in the contract, you can always call him to make sure that the data availability, data redundancy, and also the data storage is in line with your requirement to meet what needs to be done for integration of the main challenges, particularly with regards to MDMS and HES. So this must be defined very well in the specification, sir. In fact, while drafting the specification, you must also make sure that the meter specification, the HES specification, the MDMS specification, and the acquisition system specification will have to match with the integral system with which, what you're looking for. Like, the parameters, the failure parameter, the storage parameter, the redundancy parameter, the adequacy of tested data, the adequacy of the system implementation. All these things must be worked out on a clarity basis so that you will get the adequacy with the system integration solution. Is it right, sir?
Yes, sir. Yes, sir. So one more question.
Very nice question. In fact, your the other question, I will answer it actually. That is, the percentage of communication from smart meter to HES is not more than 70% at any part of the time. Is it right? That is the question?
Yes, sir. Yes, sir.
Okay?
Yes, sir.
So the 70%, how you have arrived at this particular 70%? Is it by experimentation or is it by fact data collection?
It is based on the data collection, sir. Right?
Data collection. Okay. Do you have adequate data to provide the sufficient authenticity on this?
Yes, sir.
Okay. Very fine. Then what we will do is I think probably we will systematize this particular question into different segments, and then I will answer this. And then failure of communication from smart meter to head end system is experienced. Of course, communication system, when you are choosing which communication is a prerogative of your design. In fact, you should select what is the actual best communication available in the system geographically. For example, the failure rate today, you can take mobile communication. What was during 90s and what was during 2010, 2020, there's a remarkable improvement. Do you agree? So what was available in 1990 in mobile, today most of the things are not available, and communication has become almost secure, and failure rate has become very insignificant. Do you agree? The same status quo, the same philosophy is to be adopted even for this particular system. Okay, so that is how the failure rate is one thing which answers and addresses many of the parameters, in the not only data storage mechanism, but also in the other entities of communication. So as a protocol system, you must make sure that it addresses the various incentives provided in the smart meter and AMI parameters. Okay. And anyhow, I will give you a paper actually on this particular question, what you have asked, which is highlighted in the system integration solution. Okay. Is it all right? Hello? 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 Mr. Senthil? Hello? Hello? Oh. No problem. Okay. No, actually, I am not listening to anyone actually. In fact, only. Okay. 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 How many participants are there totally? Oh, okay. The present the 46. Okay. No. What I'm trying to tell you is they could capture all the information whatever has been given. No problem. Okay. Very nice. Very nice. Okay. Okay. Thank you so much. Tomorrow morning we will see. 11:45 we'll see. Only please maintain timing because we have to rush through the presentation. Oh, okay. Oh, okay. I will answer the question in a paper and give it to you. You can circulate to all actually. Okay. Thank you so much.